So here it is told that A and B throw a pair of dice alternately. A wins the game if he gets a total of 7, and B wins the game if he gets a total of 10. If A starts the game, then find the probability that B wins. So here a pair of dice is thrown alternately. So here the sample space would be 1, 1, and 1, 2, 1, 3, etc. till 6, 6. So there will be 36 outcomes. It means the number of elements in the sample space would be 36. So let us tell that A is the event when A wins. So the favorable outcomes for the event A, that would be for A wins, that would be, so the sum should be 7 in both the throws. So it would be like 1, 6, 1, 6, and then it can be 6, 1, or it can be 2, 5, or it can be 5, 2, it can be 3, 4, or it can be 4, 3. So these are the favorable outcomes. Therefore, the number of elements in the event A, that would be 6. Therefore, the probability that A wins, that would be the number of elements in the event A divided by the number of elements in the event S. So that would be 6 by 36. So this would be 1 by 6. Okay. Then let's say B is the event that B wins. So the favorable events for the event B, that would be, so he should get a total of 10. So total of 10 can be obtained by 4, 6, and 6, 4, and 5, 5. So these are the favorable outcomes. So therefore, the probability that B wins, that is P of B, that would be the number of elements in the event B divided by the number of elements in the event S. So that would be 3 by 36. So that would be 1 by 12. Therefore, if we find the probability of A complement, it means the probability that A loses. That would be 1 minus 1 by 6. So that would be 5 by 6. And similarly, the probability of B complement, that is the probability that B loses, that would be 1 minus the probability that B wins. So that would be 11 by 12. Therefore, the required probability that B wins, given that A starts the game, so that would be equal to the probability that A loses the game times the probability that then B wins, plus we can do the probability that A loses and then B also loses, and then A also loses and then B wins, plus we can do like probability that A loses and probability that B loses, and then probability that A loses, and then again probability that B loses, and then again probability that A loses, and then B wins. So like this, I can go on till infinity. So this would be 5 by 6 times 1 by 12, plus this would be 5 by 6 times 11 by 12 times 5 by 6 times 1 by 12. Then plus this would be 5 by 6 times 11 by 12 plus 5 by 6, no, sorry, into 5 by 6 into 11 by 12 into 5 by 6 into 1 by 12 plus and so on. It will go till infinity. So we can see that this is obviously an infinite GP. This is an infinite GP with a common ratio, with the common ratio R, which is equal to this one. This one is the common ratio. So that will be 5 by 6 into 11 by 12. This is the common ratio of this infinite GP. So as we know, the sum of an infinite GP is given as sum of an infinite GP, that is given as A by 1 minus R, where R is the common ratio and A is the first term. So here, this one is A, the first term is A. So therefore, the required probability that B wins, given that A starts the game, that would be sum of the infinite GP. So that is 5 by 6 into 1 by 12 divided by 1 minus R, which is 5 by 6 into 11 by 12. So that would be 5 by 72, and this would be 72 minus 55 divided by 72. So this would be 5 by 72 into 72 by 72 minus 55, that is 7, 6, 17. So this would cancel out. So then the answer would be 5 by 17. So this is your final answer. Thank you.